Welcome back to Talk Tensors. We've got a really fascinating paper to delve into today.
Yeah, this one's called the Breeze 2 Herd of Models.
Traditional Chinese LLMs, based on Llama, with vision-aware and function calling capabilities. Quite a mouthful. Before we get lost in the jargon, can you give us the elevator pitch? Why should our listeners, who are pretty savvy in the AI world, be excited about this?
It's all about breaking down language barriers, right? Imagine AI that can understand and generate text in any language, even those with unique cultural nuances.
That's a powerful thought, especially when you consider languages like traditional Chinese with its complex characters and rich cultural context.
Exactly. And that's where Breeze 2 comes in. It's designed to tackle this challenge head-on, focusing specifically on traditional Chinese. Think about the implications for communication, for understanding different cultures. It's a big step towards a more inclusive AI landscape.
I'm already intrigued. So what exactly is Breeze 2?
It's actually a suite of two large language models, one with 3 billion parameters and a larger one with 8 billion. Both are built on the Llama 3 framework, which has really been making waves in the open source LLM community.
Llama 3. Yeah, that's definitely a familiar name.
Yeah.
What makes Breeze 2 stand out from other Llama-based models, though?
Well, it's not just about the language itself. Breeze 2 is multimodal. It has both vision-aware and function calling capabilities.
Okay, now we're talking. So it's not just processing text, it's understanding images and interacting with external systems. That's a lot to unpack.
It is. It's a step toward a more holistic AI, one that can process information from various sources, text, images, even external tools.
And respond in a way that's comprehensive and takes into account all of that, right?
Exactly. That's the idea.
My mind is already racing with possibilities. But before we go too far down that road, let's back up a bit. Can you walk us through the architecture behind all of this? What makes Breeze 2 tick?
So the architecture they use is called ViT MLP LLM, and it's becoming more and more common in open source multimodal LLMs.
ViT MLP LLM. Okay, you're going to have to break that down for us.
Sure. So for the visual encoding, they use a pre-trained intern ViT model. Think of this as the eyes of the model, allowing it to see and process images.
Interesting. So building on existing work, smart.
Yeah. And then for language processing, they use a pre-trained Llama 3 model, which acts as the brain of the system.
Okay, that makes sense. But how do you connect the eyes and the brain? How do these two very different parts work together?
Right. So that's where the MLP projector comes in. MLP stands for multi-layer perceptron, and it acts as the bridge between the visual information from the intern ViT model and the text information from the Llama 3 model.
So it helps the model make connections between what it sees and what it reads, essentially.
Exactly. Like if the model sees an image of a busy street in Taipei, the MLP projector helps it link that visual data to relevant text about Taipei, street scenes, or any other related concept.
That's pretty amazing.
Yeah.
Now, you mentioned earlier that Breeze 2 comes in two sizes, one with 3 billion parameters and another with 8 billion. What's the difference there? Why two sizes?
Think of it as different engine sizes. The 3 billion is lighter, more efficient, perfect for maybe running on a mobile device with limited resources. The 8 billion, that's the heavy-duty version. More complex tasks, higher accuracy.
So a Breeze 2 for every occasion. All right, let's talk training. How do you teach a model like this, one that needs to understand traditional Chinese, interpret images, and interact with other systems? Seems like a pretty monumental task.
Oh, it definitely is. There are 3 main stages. They start with something called extended text-to-text pre-training. It's like laying the groundwork, Give the model a massive amount of traditional Chinese text to work with.
So they're immersing it in the language, essentially.
Yeah, they want to make sure it's not just fluent, but culturally aware, too, understanding the nuances and context specific to traditional Chinese.
That makes sense. And what comes after this language boot camp?
Then they move on to vision alignment pre-training. Now they start incorporating the visual component, integrating the intern ViT model, those eyes we talked about.
It's kind of like teaching a child to read a picture book.
What?
Pointing at things and saying, this is a cat, this is a tree.
That's a great analogy. It's about building those fundamental connections between visuals and language, which is essential for any multimodal model.
So that brings us to the final stage of training, right? Where it all comes together.
Right. The final stage is called post-training, and it's all about fine-tuning and refining the model's abilities. They actually break it down into 3 parts in this stage: text-to-text instruction tuning, visual instruction tuning, and fine-tuning for function calling.
Wow, a 3-part process within a 3-part process.
Yeah.
Okay, let's unpack that a bit. What's the purpose of text-to-text instruction tuning?
Well, it's about making sure the model can follow instructions given in text format. and do it accurately. Like if you tell it, summarize the history of Taipei in 3 sentences. It needs to understand the instruction, access its knowledge base, and generate a good summary.
So it's about teaching it to follow instructions efficiently and correctly. What about visual instruction tuning? That seems particularly interesting given Breeze 2's multimodal nature.
This is where it gets really cool. Now they're using both text and image inputs. So you might give it a picture of a landmark in Taiwan and ask it to describe the architectural style of this building.
And it should be able to analyze the image, connect it to what it knows about architectural styles, and give you a coherent answer. It's like having a tour guide who understands not just your language, but also what you're looking at.
Exactly. And then there's the fine-tuning for function calling, the last part of this stage.
Which is about teaching Breeze 2 to actually interact with the outside world, right?
Right, like accessing a weather API, querying a database, or even controlling a smart home device. It's about bridging the gap between understanding and doing.
This is truly mind-blowing. We've covered a lot of ground already, the architecture, the training process, and the different capabilities of Breeze 2. But I'm really curious to hear about the data they used to train it and how they actually measured its performance on all these tasks. I guess they'll have to wait for part 2, though.
Yes, indeed. We'll dive into the training data and the benchmarks they use next time. That's all pretty fascinating stuff. So last time we were talking about how Breeze 2 learns all the things it can do, and now we're ready to get into the data they actually use to train this thing, right?
Yeah, I'm really curious about that. Like, where do you even begin to find data to train a model that needs to understand both traditional Chinese and images, especially considering those unique cultural aspects?
Right. It's a massive undertaking for sure. So for the text-to-text pre-training, they put together almost 900 gigabytes of traditional Chinese text.
900 gigabytes. Wow. And where does all that data come from?
All sorts of places. Like they did web crawls to capture everyday language use online, academic publications, news articles, even social media content.
So they wanted to cover the whole spectrum of how traditional Chinese is used, from formal writing to casual conversations.
Exactly. And they even included things like legal documents and literary works to make sure the model could handle different styles and registers. Oh, and they use dialogues too.
Dialogues, that makes sense considering they wanted to test conversational fluency later on, right?
Yeah, exactly. So that's the text side. But for the visual training data, they had to get a bit more creative.
I can imagine, like, where do you even find images that are specifically relevant to traditional Chinese culture and language? It's not like you can just Google it.
Right. So they use a combination of existing public data sets, and then they actually created some of their own specialized data sets. For the visual alignment pre-training, they tapped into data sets designed for image captioning, visual question answering.
Visual question answering, like those data sets where you have an image and a question about it, and the AI needs to figure out the answer based on what it sees.
Exactly. They even used data sets for OCR, optical character recognition.
Wait, OCR. So they're teaching Breeze 2 to actually read traditional Chinese characters from images. That seems insanely hard.
It is. Traditional Chinese characters are super complex, thousands of unique symbols, but they wanted to push the limits. So they did OCR, object detection, visual reasoning.
Wow. It's like they threw every visual challenge they could think of at this model.
Well, the goal was to make sure it could understand and interpret images within the context of traditional Chinese language and culture. They really wanted to make it visually literate.
It's really impressive. Okay, so now that we know what went into training Breeze 2, how did they actually evaluate it? How do you even measure the performance of a model that's supposed to do so many different things?
That's a good question. They actually used a whole bunch of benchmarks, like a testing ground, to assess its capabilities across a range of areas. They were very thorough.
All right, give us the rundown. What kind of benchmarks are we talking about?
So first, to assess its general knowledge and understanding of traditional Chinese, they use a couple benchmarks called TMMLU Plus and MT-Bench2W. TMMLU Plus is like a giant comprehensive exam for AI, covering everything from science and tech to history and literature.
Sounds intense. So it's not just about knowing the language, it's about knowing the world through the lens of that language.
Right. And then MT Bench 2 focuses more on conversational fluency, making sure it can hold natural-sounding conversations in traditional Chinese. Super important for things like chatbots or virtual assistants.
Makes sense. What else did they test?
Well, to see how well it handles long context, they designed a clever task called the passkey retrieval task. The model has to sift through a huge document, like 128,000 words, and find a specific piece of information hidden within it.
Like finding a needle in a haystack.
Exactly. But both the 3 billion and the 8 billion parameter Breeze 2 models were able to find the passkey accurately and efficiently. It shows that it can understand relationships between sentences even when they're far apart, which is crucial for things like summarizing articles or translating documents.
So it's not just remembering individual words, it's understanding the overall meaning and flow of a long text. That's super important.
Right. Then they also tested the function calling capabilities. Remember, that's its ability to interact with external systems and tools.
Oh yeah, like using an API to get weather information or controlling a smart home device. So how did they test that?
They used benchmarks like the Berkeley Function Calling Leaderboard BFCL, both in English and a translated version for traditional Chinese.
So making sure it can use these tools effectively in both languages.
Yeah, it's about more than just understanding what the function does. The model needs to know when to use it, how to format the call correctly, and when not to use it if it's not relevant.
So it's like making sure it's not just pressing buttons randomly, but actually using the tools intelligently. Did they test anything else? We haven't talked about the visual understanding benchmarks yet.
Right. For that, they used MMMU, which focuses on complex reasoning about images, and then they created their own benchmark called TMM Bench, specifically for traditional Chinese.
TMM bench. Tell me more about that one.
So TMM Bench is all about evaluating the model's understanding of images and text related to Taiwan specifically, like questions about landmarks, daily life, even images with traditional Chinese characters.
So it's testing that cultural and visual literacy, making sure it understands the nuances of Taiwanese imagery. That's really clever. And how did Breeze 2 perform on all these benchmarks?
It did remarkably well. It showed strong performance across a wide range of tasks, suggesting that it's a big step forward in creating a truly multimodal and multilingual AI.
That's incredible. So we've covered the architecture, the training data, the rigorous benchmarks, and the impressive results. But what does this all mean for the real world? Like, what are the practical applications of a model like Breeze 2?
That's the exciting part. The possibilities are vast. In fact, the researchers already developed a mobile app powered by Breeze 2.
Whoa, hold on. A mobile app? That's amazing. Tell me everything.
It's designed for users in Taiwan specifically, and it basically showcases all the things Breeze 2 can do in a way that's easy to use. You can give it text or images, and it uses the model's capabilities to provide info, translations, even insights.
Can you give us a specific example?
Yeah. Imagine you're a tourist in Taipei, you see a cool historical building, you can just take a picture with your phone. And the app, using Breeze 2, will not only identify the building, but also give you info about its history, architectural style, and cultural significance.
That's like having a personal AI tour guide in your pocket, and it's all in traditional Chinese.
Yep. The app's tailored for traditional Chinese speakers, allowing them to interact with Breeze 2 in their native language. It's pretty awesome.
I bet making a mobile app powered by a model this complex was a challenge in itself.
Oh, for sure. The researchers talked about the difficulties of optimizing Breeze 2 to run efficiently on a mobile device. They have limited processing power and memory compared to those giant servers used for training.
So how did they manage to squeeze this sophisticated model onto a phone?
They used a tool called Executorch, which is designed to optimize these large-scale models for mobile platforms. It even takes advantage of hardware acceleration using the AI capabilities built into modern smartphones.
Smart. So they were able to get it running smoothly without sacrificing too much performance.
Yeah, exactly. There are still some limitations, of course. Breeze 2 is still a pretty resource-intensive model, even with the optimizations. It might struggle on older phones or if you have a bad internet connection.
Yeah, that makes sense. It's like trying to run a high-end video game on a really old laptop. You have to compromise somewhere.
A perfect analogy. But those limitations are likely to decrease as mobile devices get even more powerful. And the researchers are already thinking about future directions for this work.
Oh, what are some of the things they're looking at?
They want to keep improving those vision language capabilities, making it even better at understanding how images and text relate to each other. They're also thinking about exploring even larger model sizes, which could lead to even better performance.
It's like they've opened a door to a whole new world of possibilities, and now they can't wait to explore it further. Speaking of exploring, it's time for our Novel Notions segment, where we take the research and brainstorm some potential extensions or future directions. Ready to dive into some speculative but thought-provoking ideas.
Absolutely. Let's see what novel notions we can cook up based on this groundbreaking work. All right, so novel notions time. We've seen what Breeze 2 can do, but where do we go from here? What new avenues could this research open up?
Yeah, let's get those creative juices flowing.
Well, one thing that really jumps out is the power of combining language and vision, right? Breeze 2 shows us what's possible when you bring those two things together.
Absolutely. So what kind of tasks could we tackle with this kind of multimodal understanding?
Think about something like art history. Imagine a model that could not only analyze the visual features of a painting, the colors, the composition, but also understand the historical context, the symbolism, the artist's intentions.
Ooh, that's fascinating. It could even connect the painting to relevant text, like the artist's biography or critical reviews from that time period.
Exactly. It's like having an AI art historian right at your fingertips. Students and researchers could use this to explore massive art collections in a whole new way, uncover hidden connections, generate new interpretations.
It would be revolutionary. And I bet this kind of approach could be applied to other fields too, right? Not just art history.
Oh, absolutely. Think about medical diagnosis. A model could analyze medical images like x-rays or scans, understand patient records, and even factor in the latest medical research to come up with more accurate diagnoses.
Or how about architecture and urban planning? A model could analyze blueprints, take building codes into account, and even incorporate feedback from residents to design more sustainable and user-friendly cities.
Exactly. The possibilities are pretty mind-boggling. But we have to be realistic too. There are challenges ahead.
Yeah, what kind of challenges are we talking about?
Well, it's not just about having bigger data sets and more powerful algorithms. We need to figure out how to effectively combine different types of information. How do we represent knowledge in a way that works for both visual and textual processing? And how do we make sure that the model's interpretations align with human values and understanding?
It's not just about making the model smarter, it's about making it understand the world in all its complexity.
Right. But I'm confident that researchers will keep pushing the boundaries. We're going to see some incredible breakthroughs in multimodal AI in the coming years.
I can't wait. Well, I think we've covered Breeze 2 pretty thoroughly today. We've explored its architecture, the training process, the impressive results, the potential real-world applications, and even some exciting future directions.
Yeah, it's been a great discussion. Breeze 2 is a really significant achievement. It shows us the power of AI to break down language barriers and help us better understand the world around us. I'm excited to see where this research leads.
Me too. And as always, Talk Tensors will be here to keep you updated on all the latest developments in AI, breaking down complex research and exploring those mind-blowing possibilities. So be sure to join us next time for another deep dive into the world of cutting-edge machine learning.
Until then, keep those brains buzzing.